Good morning, everyone. This is Scott Stengel from Melco Applications team, here with Nate Moore,
Hey.
my old friend, and we're going to talk today about kind of trying to demystify the differences in wireframe versus expanded stitch files. What's the difference? What advantages, disadvantages? Does it matter which one I sew? All that kind of stuff. Good. Not streaming?
You're recording but not streaming. You hit the wrong one.
Oh, so we're starting now.
Okay.
Ready?
Yeah.
Okay, go. What did I hit? Stop recording?
You hit... There you go.
Good. All right. Good morning, everyone. This is Scott Stengel from Melco Applications team, here with Nate Moore.
Hey.
Today to talk to you kind of about trying to demystify the difference in wireframe versus expanded stitch files. Sort of what advantages does each one have? Disadvantages? Am I going to get different quality when I sew one versus the other? How about scaling? All that kind of stuff. So we get a lot of questions on this, and hopefully this will clarify some of it for you if you have different questions. Feel free, please type them in and we'll answer them. Also, this is going to be recorded, as we do with all of them, right after it's finished. And we'll put it up online. Alright, so of course there's between like 25 and 30 different embroidery file formats out there. I don't know why we need that many, but basically they are, most of all of them, expanded stitch files anyway, can be read by Design Shop. So kind of whatever expanded file, these are like DST, EXP, PES. Those file types you can read right into Design Shop or into our OS. Alright, so I'm going to start with a little history. I think this is kind of cool. I started in embroidery back in 1985 out of school. Melco is my first job, and here I am 33 whatever years later, 34 almost, still loving it. So I've seen some kind of old-time stuff that I think is just fun to share. So we'll just take a couple of minutes and go over that, and then we'll get to the wireframe versus expanded. So this is a cool picture. This is from credit to St. Gallen Embroidery, which is over in Switzerland. I went over and spent a week over there. They have these huge embroidery machines that are called shuttle machines. They do the continuous fabric like you see on drapes and on fashion garments and all that kind of stuff. Interesting. And so this shows a digitizer from probably 150 years ago, and here's how the process was done. So they would draw a cartoon, it was called, or a picture that was 6 times the finished size of the embroidery that they were going to sew. And every other stitch was drawn on this artwork. It's not a really good picture, but still kind of explains it. And this represents the needle, and so the guy would move to the first needle penetration. He would pull a lever, hit a clutch with his foot twice, and the machine would make 1 stitch. All this, the needles go in horizontally instead of vertically like they do in our embroidery. So very interesting stuff. Then he would move to the next needle penetration, pull the handle, hit the clutch twice, make another stitch. So every design, every run had to be digitized from scratch. There was no machine memory. They didn't have paper tape or Jacquard or any of that kind of stuff. And even in 1985, there were some places that still used this method because it worked so well, and hey, a machine was paid for, right? So it was kind of cool. The reason this was 6 times larger is it was geared down. So the movement that this guy did was reduced by 6 times through the gears when it came to move the rack. So it had to be 6 to 1 positively. So no storage of designs or anything like that. Then later on came Jacquards. We kind of studied some of that in school. And then from Jacquards, which were very wide, punch cards before that, they went to 1-inch paper tape. So that is this right here. And this is kind of when I started, around the mid-'80s. So has a feed roll. it's 8-channel tape. Every 3 lines is 1 stitch. So one is X direction, one is the Y movement, and the third is a function code like a color change or a move without stitching, which would be called a jump stitch and things like that. So the only editing was to find out, where you were in the tape and then add holes or splice in things or something. It was really, really hard. But this is sure a lot better than having to digitize it each time. Machines had no memory, and so you had to run the paper tape every time you ran the design, which is okay, except after a while these feed holes would get elongated, and if it couldn't figure out, one run where the holes weren't lined up, it would just stop and all your garments are ruined. Pretty interesting, huh?
No, thank you.
The guys I learned from, though, they could just peel through this paper tape and they'd know exactly where they were in the design, and they wanted to move a fill up or down or do something like that. They would punch new holes in and change the way the embroidery sewed, or its location anyway. So pretty labor intensive and not a lot of flexibility. They were still digitizing stitch by stitch, however. So this is how the term punching came around, because the digitizer would hit, the button, and it would punch the hole for that stitch in the paper tape. So the guy that did that became called, the puncher. And many of you probably haven't heard of punching now because it's kind of been replaced by digitizing. But if you do hear the term, let's get the design punched, or what does the puncher say, or something like that, you'll kind of know more. Right?
Yeah.
Okay. So after that, Melco, what got us started in 1972, we started producing, or we're developing a product called the Digitrack. And I will show you this guy, that's me. Back in 1985. So this is Melco's first product right here. Same cartoons that I talked about in the St. Gallen embroidery picture. But this was the first machine that allowed you to do outlines like a fill. You could tell it what the border was going to be like and then give it the stitch recipe inside it, and it would take and generate the whole thing. So very revolutionary compared to having to digitize your every stitch every time. And that kind of put us on the map. This is, like I say, about the time that I joined them. So this machine would actually save your design to a floppy disk, which is 5 1/4. It would punch the paper tape, which is right over here in case you needed that for older machines, and it would do a sew out at the same time, all at once. Pretty cool. And it would punch the tape as you digitize. So if you were doing walk stitches, every time you hit a button, sort of like a left or right click, it would spit out a small amount of tape. When you did a fill, it would wait because you haven't finished the fill till you digitize the last point, and then it would spit out the whole thing. So you could hear these different places going off when they were digitizing different parts of designs. It was a very interesting time. We also went to Mylar tape at that time, so you couldn't get the elongation of the holes, and everything lasted long. Pretty interesting though, huh? Isn't it? Yeah. Then Melco came out with condensed disc format, so that's kind of the first wireframe format that existed. It's been retired since then. It's so old, but been replaced by OFM. Basically, is what happened. So it would store wireframe data, but no color info, no artwork, no notes, nothing like that. But still, what an advancement! You could scale designs, do stuff like that, but no editing. After that. The industry kind of switched away from this machine. This was $25,000 in 1985. So really it became people that just either owned a huge company and digitized for their machines, or people like me that digitized for other multi-head places that didn't have their own equipment, weren't interested in doing it, left it up to the experts, and we had really good designs. A lot more expensive than it is today though. So everybody switched to boards, which is kind of like a laminated 3 foot by 2 foot roughly board. that had a circuit board underneath it, and you had kind of a mouse with a crosshair on the front. Is how I can explain it.
Yeah.
And as you moved around the artwork, it's sort of like today on screen, but you did it to a cartoon. There's a better picture that I have. This is from John Deere. Kind of shows more of a normal piece of artwork up on here. This would be a logo, so 6 times larger. Crosshair was right here. You hit your straights and curve buttons up here and moved around. It was a beautiful machine. It really was excellent. Okay, so then after it went to boards hooked up to the machine, no editing, finally computers with DOS came out, and so you could hook this machine, or a bit pad as it was called, right up to the computer, and now we finally had editing. Before that, if you made a mistake, you got to either edit the tape or start over. So it was quite an advancement, even on a slow computer that cost about $10,000. It really sped things up and added a lot. No stitch effects, no automatic underlay, lock stitches, nothing. You had to digitize everything from scratch. So it was interesting. Last week we did the session, and a customer asked, "You digitize your own excuse me, you digitize your own underlay?" And I'm like, "Yeah, I did, because that's what I learned, and there was no other choice." And so it's just a way that it started out and kind of evolved from there. But I still do small fills. I just do my own underlay and move on. It's just faster. So then they moved to on-screen, which got rid of all the boards, and that's kind of where we are today. I guess the last thing that happened is software added the ability to convert vectors to stitches automatically, and that sort of changed digitizing somewhat. It's a tool. It's not an end solution all the time, but it is a very good tool. What's funny is now people think that embroidery is so advanced at the trade shows and sometimes other places. People will come up to us and say, "So your machine reads JPEGs, right? Like you could hold a picture of your dog in front, up to the machine and hit start." Of course, we know it's not that all automatic, but people tend to think that it is, that don't understand embroidery. Okay, hopefully you enjoyed a little bit of the history that I had, and now we'll move on to what is the difference in the 2 different file types. Basically, we have wireframe versus, like I said, expanded stitch files. You can kind of think of the wireframe, it's always preferable. We've kind of been over that a bunch because it gives you the most flexibility on scaling, the best results, and all that. So think of the wireframe as kind of the master file. If I wanted to go back and look at the artwork and see why something didn't come out or it needs to be modified, I would want to look back at that artwork. So the wireframe file contains all sorts of additional stuff to help digitizers and people like that. When it comes to the stitch file, you think about what the machine needs. The machine only wants to know where it needs to move next and drop the needle. It doesn't need artwork, it doesn't need notes, it doesn't need all this. Just XY locations of where to put the needle down.
I often would compare it to reading and writing a word processor document. You can read it, you can write it, you can change the spelling, you can do all of that, and then you could essentially save it as a PDF. And the person who gets the PDF could read it and they could print it, but they couldn't really change the spelling.
Exactly, yeah.
So that whole editability thing, that's where we live with the wireframe. Why we prefer it is we can get in there and essentially change the spelling. But if all you're going to do is read it or print it, then and not try to scale it, not try to do any of that, that's when you get into those expanded stitch files.
Exactly. And it's really important to understand that even if you're running an expanded stitch file, you're getting the stitches and the quality that the digitizer gave you. If you sew a given file at that size, there is really no difference in quality in having a wireframe versus an expanded stitch file, right? Because they kind of end up the same when they get to the machine. Okay.
Yeah, as long as it's just the stitches. There will be some efficiency things like our wireframe holds color information. So there are things that I'll know that I can send to the machine, like, oh, that's going to be red, and I'm totally going to do that. But you'll see when Scott starts pulling stuff up that maybe that's not the case with some of those stitch files.
Yeah.
So yeah, the XY, all that's great. It's just some of the extra stuff.
Yes. In a nutshell, you can kind of compare wireframe versus expanded to sort of printing. There's vectors and there's rasters, and so we have, of course, vector tools in Design Shop. So I'll just do a simple fill for you. Something, let's say like this. Boom. Okay. So in vector, you can see how beautifully clear this curve is. There's no steps or anything like that. It's just gorgeous. And what happens is, in vectors, the outline is stored at a very high resolution, so it'll scale very well. And it's also told, hey, inside, in this case, fill it with a color blue of a certain RGB value. So when I take this and I scale it huge, we'd get no loss of quality there at all. I can move this thing up or down huge amounts and still get crystal clear edges. That's the benefit of vectors, and that's also the benefit of having a true wireframe file that was created in this case, Design Shop software. So it's always going to be preferable if you're going to scale up or down, if you're going to cut and paste between logos, take the beach ball from this design, merge it with the palm trees from another. Stuff like that is going to be it's going to go very much easier if you use wireframe. However, like we said, if you're just going to open and stitch, the expanded file will give you beautiful quality also. Okay, so then if we switch, and I'll show you, here's another one that came in. This is in your software, kind of a sample for the photo fill feature if you have that. But here is one of our employees' daughter who is now in college, Nate told me.
I think that's right. I don't think I'm lying.
Close anyway, yeah. If I look at this, you can see that it's a little bit blurry, but you can still see definition in all the different colors and how they relate. This is a JPEG, so this is done in dot formats. So the larger I make this image, the more spread out all the dots become, and then I start losing quality. So I just took this one here and I scaled it up. And you can see how I see a lot of squares instead of a smooth transition between the different colors and all that. That's in a nutshell what happens with the expanded stitch files when you try and blow them up 30% or shrink them way down or do stuff like that. There is also software in Design Shop called the Expanded Stitch Processor that we will, when you scale and expand a design, we will automatically add or remove stitches based on the size. You can fatten things up, you can do stuff like that. So you kind of have to see this in terms of no stitch processor, just either moving the stitches out farther apart, which is going to give you poor quality, no coverage, all sorts of stuff like that, versus having an expanded stitch processor now. Good?
Yeah.
All right, so I'll get rid of this one. So like we said, this relates to OFMs versus stitch files. So what's included in each file? So basically in your wireframe, which is our OFM file now, we get wireframe outlines like I showed you on the vector fill, stored in high resolution, so you get really good scalability on stuff like that. And the stitch properties, or you can kind of think of it as the recipe of what goes inside. So if I take wireframe, a fill, and I scale it, it gives a great outline because that's stored in high resolution, but then it will also get the recipe and make, new stitches every time that you stretch an edge, scale the size of it, stuff like that. So it's pretty much like starting over instead of just taking what you have and spreading it out or smashing it more together. Second thing that's beneficial for wireframes is it stores color information. The expanded stitch files, most of them, at least the most common, which are DST and EXP, they have no way to store color information. Some software out there will put a hidden file in that has the color information in it, but the file, the DST or the EXP, have no way to store colors. So we have to display something, for you when you open an expanded file. So that's why you always get the same colors of red, green,
blue, dark blue, pink, purple. I used to know that sequence by heart, and I don't remember it anymore.
Yeah, because we have to, put up something for you. It's still going to be to your advantage to take those expanded designs, colorize them to your thread colors so you know what green to put on and all that kind of stuff, and save it as an OFM. But know that it's not a true native OFM that was digitized in Design Shop. But it's still better than saving just the expanded. It's better to save them as an OFM. Also included in the wireframe files are expanded stitch locations. That's just move here, drop a stitch, move there, drop another stitch, on and on and on. Why would that be important? Well, really not, because you're going to be working off the wireframe when you have OFM files. What this gives is the ability to share a file with somebody that you created on, say, version 10, which is our current version of Design Shop, and you can share it with somebody who might have a very down-rev version of Design Shop. In the past, all the software I used, it would say, hey, sorry, you can't open this. It was created with a newer version. Go back to the person and get a different file or something like that. This allows us to give the down rev person at least the expanded stitches and the color information so that they can run the order.
This will also allow you to, say, take an old expanded design that you've just had, which is just expanded data, right? And you can open that up, colorize it, just like Scott said, but then you can add lettering above it. So you have the wireframe information for the lettering, but we're not going to really mess with that expanded, so it will still hold that expanded data. And you can still have the editability of the stuff that you've added. So you can have all of these. You may not have all of it in a file, but you have the ability to have all of these pieces in a wireframe.
Definitely.
True
advantage. Also, we store the artwork, whether that's EPS that you have, vectors, or JPEG, bitmap. There's just a whole bunch of different formats you can use. That, like we were talking earlier, is nice for the digitizer or somebody to look back at and see, what did we do? I even had people that would go, hey, that design you did runs great. Now the customer wants a screen print shirts. Do you have that art? And so I would send them the EPS. I'd extract that out of the file and send it to them like that. Huh?
That only works with vector.
Yeah, vector only. And then we also give you the capability to store notes. So you can put, hey, use these kind of needles, whatever special notes you want to have for you or your production staff, that can also be stored in the file. So you can see there's a lot going on in the master file, and very beneficial to have it store all those different parts. Now we get into the expanded stitch files. So these are commonly EXP, DST, PES. You can see under File Open in Design Shop the whole list. It's just absolutely crazy. And all that's in the expanded stitch file is just, like we said, the expanded stitch locations. We remember from math X, Y, move over X, then move up Y, and that's your ordered pair. That's all that's stored in there, as well as function commands like, change colors at this point. Not what color is stored, but hey, at this point, change to another needle. Or if it's a jump stitch, which is movement without stitching, or if it's just a drop the needle, we're going to make a stitch here. Some of the other formats, PES and others, they will hold hoop and thread color information, very basic palette on something like this, but that is all that is in the expanded stitch file. Now, go ahead, Nate.
I may be jumping right to where you're going to start talking, but like Scott said, you know, EXP has a slightly different set of things that it will hold than DST, and DST will hold slightly different than a PES. Some of those files, like EXP, can contain a trim command. Other files, like a DST, can't. And so they will sub out for a trim. When you save out as a DST, it will say, okay, I know I can't hold this, so what do you want me to put in there instead? And we'll put in X number of jumps, and you specify that number of jumps. Then you might be looking at me cross-eyed through your screen right now, while when I open a DST, I see trims. We have a filter that hops in and says, if you see this number of jumps, go ahead and sub back out a trim, so that we kind of read it back in and kind of convert it back over. The biggest trick for that is to make sure, if you're dealing with these types of files, that those numbers pretty much match for your machine and your software. Otherwise, you're going to be missing trims where you want them or getting trims where you don't.
Yes. So another sort of side note on there is, if you take that DST, colorize it if you like, but save it as an OFM, when it trims is going to be sort of permanent, not based on what you set Design Shop jumps to trim or whatever to.
I'm sorry, I was reading at the same time you were saying that.
Makes sense to everybody. If you have a DST, what you're setting at in both Design Shop, under Tools Settings, jumps to trim, and in OS, that decides, do we want to trail the thread and leave it, or do they actually want to clip it?
Yeah.
So if you had just a DST, whatever that setting was, if it changed in your software, it's going to affect how the machine trims. Whereas if I save the DST as an OFM, what that setting is like permanent. So
yes, that's a really good point.
That's going to save things.
Super helps if I don't read when you're talking. Except I was reading a question and wanted to get a reply. The question was, does OFM stand for anything? And sort of, yes, it's an object-based format.
Yeah.
So your object-based wireframe, it's all kind of the same whatnot. You're dealing with elements that you're going to be able to move around and manipulate. So that's what that was.
I think, EXP is expanded, right? I think because Melco came out with Condensed, which is their first wireframe, the opposite of that.
It totally makes sense.
Expanded, but expanded, so it helps a lot of times if we refer to them as stitch files, because okay, I understand what that means. Okay, so let me show you here. Open. Here is a sort of a sample. This is just wireframe elements, right? So you can see in the stitch list we have complex fill, column 1, walk stitch. Here again you can see that it's stored in the very high detail outline like we talked about. And if you look at both of these, the stitches are pretty nice and spread out nice and evenly. Well, the problem with it is you're never going to be able to sew your OFM. You couldn't sew it direct. It has to be clamped, the stitches do, to embroidery's resolution, which we've talked about before. It is down to 1 point, so there's 256 possible points in an inch, both in X and Y. That's our resolution. OFMs, they store things in much higher resolution than 1 point. So people ask, well, how come the thing looks so terrific on the screen in an OFM, but then when I look at it in OS, or I make a expanded version for another machine or whatever, it doesn't look the same. It's because we have to take the stitch data and clamp it to embroidery's resolution. So I digitized this real quick to kind of show you some shapes. Another question that comes up is, well, okay, if my my density is 4 points, let's say, like we're pretty much used to, that's easy to do. I just come and I go 4 points over, drop a stitch, another 4 points, drop a stitch. Well, let's say that I sewed this and I realize, that didn't quite cover. I need a little more density. So we might go down or increase the density to, say, 3.8 points. So the machine's like, what do I do now? I can't go a part of a point because my resolution is to 1 point. So the choice is to change the spacing of the stitches that will give you your desired result, but if you look at it up close, it looks clumpy. That's a word I came up with.
Yeah, you can zoom in, and you'll see them grouped, and if you count it out and do the math and average, and I don't know why I sit in here and you make me do math, and I hate math, but you do it to me all the time.
Do I?
Yeah. But it's totally doable. You can look at an expanded one and you can measure and go enough, and if you average it back out, it will totally be exactly what you're talking about. But you will see those pairs of stitches that are a little bit tighter or a little bit looser than everybody else, and that's what's going to make that happen.
Yeah. So I just quickly threw this together with different element types so you could see. So this is the wireframe, but I also took this and I saved it as expanded so that you can see the difference. So now all I need to do is just insert the file. Here we go, and I take this and I'll put it behind. And this is kind of hard to see colors, so I'm going to change.
I was going to say, you put opposite colors.
Yeah.
It's going to hurt.
Hold on.
One other thing, and I'm going to blame Scott for looking at a computer monitor when he said this. He said there's 256 points. There's not. It's 254.
I'm sorry, 254.
No, yeah.
Oh, sorry.
That's a metric to standard
25.4.
yeah.
Excuse me. All right, so here is a hotter red. So if I line the two files up and I zoom in, you can see that they don't quite line up here.
So close.
Right, they are. And what makes it even better is I can select it, and if I do properties, and I can show you this, there's a view tab. And I can show the expanded needle penetration so that you can see the difference in the two. You could also show wireframe points or lines. Sometimes that helps you kind of see what the edge is like better, but we'll do expanded points here so I can show you this. Now, when I zoom in, you can see that stuff isn't lined up. You can see this good. You see right here, these are off. Every single one is not exactly the same as the green. Well, part of that is, we're clamping it, like we said, to embroidery's resolution, and some of these points could be off. They fall a half a point somewhere, so the software will automatically adjust. Like you're ever going to notice that, 1/10 of a millimeter, right? You're not going to know that, hey, totally that's a little to the left.
You're not going to see that.
But check out the columns. So here we can see that it had to move it over because it's same deal on the fill. It wasn't quite close. But let's look at the curve here. If I look at just the wireframe, it's very nice and even, spaced out perfectly along the ring. That is not realistic because that is too high for embroidery's resolution. So sometimes if you see the expanded version, you see that, hey, these aren't really lined up. They're kind of off. They're a little bit clumpy. Here's what we talked about for the density. You see that it puts more in one place than in others. So if I compare right here, this one I used a lot of density because it kind of shows things better. Here you can see how the stitches are not uniformly spaced, but the end product still shows you on the fabric what you're looking for, which is even, smooth density that covers fully. Look at this. This is how it has to stagger closest to 1 point increments. Now you'd never see this really on the fabric.
Yeah, keep in mind, guys, you are super zoomed in, 5,000%. You'll never see this.
Yeah, you won't. But you can see why there is a difference, and the expanded will always look more clumpy, I guess. So in Design Shop, to make it look realistic like it's going to be on the fabric, we're going to space the stitches out to kind of show you what you're going to get on the finished product. But know that they group and clump together and do stuff that just has to be done for embroidery. Every software has to do this. You have to get to embroidery's resolution.
I think this is where your raster image comes back really well. You can look at those red stitches and see that they hit a grid, and you can see that grid pattern start to form.
Yes.
I think that's a perfect analogy for that.
Good. Alrighty. So the pros of cons. Obviously the wireframe, the pros are you're going to get better editing, you're going to be able to hold color information, your scaling is going to be so much better because that outline is high resolution and it's going to regenerate the stitch pattern every time that you do something with it. The art and the notes are awesome to store in the file for later. But stuff like lettering properties. So let's say I digitized the design, I ran alphabet text as part of it, I saved the whole thing only as DST. Well, now I want to change the spelling or do something. It's not, wireframe anymore. It's just expanded stitches. So you always have to save that wireframe, and you can see the benefits of having all those properties, color information, everything stored in the file. The cons, larger files, I guess, so what? These are really small files to begin with, so not an issue at all today. It will reduce your artwork file size if you have JPEGs and stuff like that to make the file manageable, because you don't need a 10 meg JPEG usually. The drawback is also, another drawback would be that you need to have Design Shop to read the OFMs. You need to have the same software that the file is created on in order to be able to use it.
Is that drawback really?
I don't, yeah.
No, you should have Design Shop, totally.
Just people go, I got this file, what do I do with it? Or sometimes you get master wireframe files that you can't read it with anything except that specific
I get it.
level.
It makes it a little bit harder to share.
Share, yeah. And we already talked about if you have a downread version of Design Shop, you can still read OFMs that are created later because of our universal OFM format. Expanded stitch files, the pros. Biggest one is any embroidery software, machine software can open the file and they will get the same stitch quality that the digitizer plans that you would get. There's another thing like we talked about, being able to take your EXP or DST file and colorize it and save it will help you in your production and remembering colors and all that kind of stuff. What you have to be concerned about is you go find a new digitizer and you say, hey, I have Melco equipment, I have Design Shop, so I would like to have OFM files. And they use a different system for digitizing than Design Shop, so they find a copy of our Sizer, which is basically allows you to run OFMs, scale them, colorize them, save them as a different format or whatever. And some places will digitize, they will save the expanded, and then they'll run it into Sizer and save it as OFM. Here you go, here's your OFM, and you look at it and it's all expanded. So be careful about that because it is not native. It's not going to scale as well as true native OFM digitizing that's done in Design Shop.
So that halfway covers one of the questions.
Okay.
One of the questions is there a way to convert a file created in EXP from another software to OFM and be able to resize and scale? And that's the sticky little question.
It is.
The answer is absolutely, of course. The other side of that is how effective is it and what are you really trying to do with it and what's going to give you the best quality. So I remember you talking a little bit about expanded stitch processing and what that does.
Yes.
You're going to be getting into that?
No, we sure can. We can.
Just or convert to wireframe real quick and show kind of what that does.
Yeah. So also there, heads up, I wanted to give you on this, so I wasn't gonna do a whole spread on how to do expanded stitch editing. Is stored on our recordings. We have I did one 45 minutes, I think it was, close to that. It's called Going Deeper into Digitizing, Expanded Stitch Editing, and this was from like October. And we go all into how to add trims to expanded designs and how to split element and cut and paste. And
Did we convert in that? I don't remember.
yeah, we
Okay.
showed. So the scale key, I guess, is what
okay.
I'm talking about. So if we'll just take this expanded part down here and just throw out the wireframe. So let me just turn off View tab. Get rid of the expanded points and kind of move this off to the side. We'll get this up here so you can see better. So if you have expanded and you want to, it depends kind of what you want to do to it, right?
Exactly.
That is just huge. So think of sort of the tools to manipulate or features we have is I can add or remove density to fills, walk stitches, satin stitches separately. And I can fatten things up, add pull offset like we've talked about as your friend. If something was scaled down and then you need to fatten it up again, you can do that in the scale key, but you're stuck. I mean, since it's all just XY stitch locations, which you can see here. Here's the X value, here's one stitch. X value, Y value, how long the stitch is. This can be to your advantage to go through, and if you see a lot of 1 and 2 point stitches, you know that that's where your thread breaks are happening because you're not getting movement. So I can fatten up, I can increase density. What I can't do though is go, oh, you know what, this fill sews from the bottom to the top. I really wish that it would sew for here, walk up, sew down, and exit here. You have to convert that back to wireframe in order to do that.
And
you're adding distortion.
a little bit. I mean,
You
you're
do that.
processing, it's doing its best to figure out what it does, and we've done videos on this in the past, and I'll try to find those and get those links out. So to answer the question, which we got a little bit more details, and that's when you heard me go oof, was it sounds like trying to change the stitch type of an outline.
Yes.
That's going to require some conversion, or honestly, for what you're dealing with, I would probably digitize over the top of it, because here's the kicker, she's working with a distressed font that's an expanded.
Oh, yes.
So it's going to have holes and chunks taken out of it, and that just is going to be rough on, sorry.
And it'll look good.
On the conversion. I would digitize around it myself.
We do that sometimes, yeah, just exactly like Nate says. You got a problem with one part of the design, you can use sort of the bad border as your artwork, digitize a quick element over the top and replace it with the other one.
Those distressed typefaces are very popular, and they are just tricky as all get out because of the complexity of the overall shape.
So many parts.
Right. So to try to deal with that and convert that, and then go back in and find the pieces that you don't want and delete those, and get a smoother edge, and then change the stitch type. I think it would be faster and less headachy and require far less coffee if you just digitized over the artwork yourself.
Right. And so another thing here is, let's say this is my entire logo that's made up of a bunch of different elements. If I just needed to add density to this fill, it's going to be to my advantage to select just the fill and right click operations. This is where we convert to wireframe. So I converted this one element to a complex fill, but I haven't messed with any other parts of it. You get a little distortion, like I say, and the more times you do it, the more kind of the distortion adds up. So if you only want to work on one part of a design, if you can select it in the object properties list and convert that, you're going to be in better shape than doing the whole thing.
Yeah, that's totally, like, if you need to edit something and expand like that and need to convert it, I would grab only the piece that you need to deal with. That way you maintain the fidelity of everything else.
And some stuff you're going to lose, like pattern fills and all that. It's not going to convert that and remember and back. Yeah, I mean, the way the process works is it will look through the expanded stitch list and it'll go, oh, you know what, like from this stitch count to this stitch count number, these are all kind of, every row has no Y movement and they're all 40 points apart. So, you know, from here to here, I'm going to call that a fill. And so then it goes backwards, puts an outline around it, you know, kind of erases the stitches and figures a recipe. So that's how it converts back to wireframe. But
you'll also notice that you won't get you won't get any truly complex fills. You'll end up with a lot of simple fills. So if you have a fill that meets back up with itself and you have a travel stitch, you'll get a fill for the bottom, a walk stitch, and a fill for the top. And you can delete that walk and make sure they overlap and combine them. But again, you're editing and converting and doing all of these things. So just keep an eye on that. And I vaguely remember doing that in one of the videos. I think you've done it in one of them. Yeah. So I'll try to go back through the library and find those again.
Yep. So hopefully we demystified difference in wireframe versus expanded. Also, if you're looking for a list of OFM digitizers that do it native, we have that on our melco-service.com website. FAQ, frequent asked questions, just type in digitizer and you'll get a list of, 5 or 10 of them that we have on there that produce good quality. Most are OFM and good people. And hopefully this takes care of your questions. Feel free to keep asking. We'll keep checking this, and we're going to put it up, like I say, as soon as it's done, so everybody can watch it later.
So I'm going to try to sum this up.
Go ahead.
OFM.
Yeah.
EXP. Great if all you're going to do is sew it. If you're trying to edit it, not so much.
Exactly. Yeah, but please understand that EXP, expanded designs, will sew really good untouched if that's what you want.
Yeah.
Harder to mess with though completely. Okay, well, we'll look forward to seeing you next time, and everybody have a good day.
Thanks everybody.